Hi, today's lesson is on rate and work. Rate measures the amount of time it takes to do a certain amount of work. That work could be anything. It could be traveling a certain distance, or it could be painting a wall, or it could be waiting for your coffee to cool. The rate comes in when we measure the time for that work to happen and we relate the time and the work to give us a rate at which that work happens. Let's look at the most common example of a rate. It's called speed. Here we're relating distance and time. If you travel a certain distance in a certain time, then the speed or its rate is distance over time. So speed is a measure of how much distance you cover in how much ever time. For instance, if you cover 5 miles in 2 hours, then your speed would be 5 miles upon 2 hours, or would be written as 2.5 miles per hour. Effectively, you've traveled 2.5 miles in every hour. Therefore, you covered 5 miles in 2 hours. Speed captures that notion. We'll dispense with the basic examples where 2 of those unknowns are given and the third has to be found out. And we'll just move on to some slightly more complicated examples where something more is happening. A man cycles 30 miles from point A to B at a speed of 15 miles per hour. If he returns along the same path and the entire trip takes 3 hours, at what speed did he return? He goes from A to B at 15 miles per hour. And we want to know at what speed he returns. We know this distance is 30 miles. We also know the total time for the journey was 3 hours. For the return journey, we know something. We know that the distance was 30 miles. They've asked for the speed. What else do we need to know to calculate the speed? We need to know the time taken to return. If we knew the time taken to return, having the distance, we can easily calculate the speed. So let's find out some of the times taken. What was his time taken to go from A to B? Well, he went from A to B at 15 miles per hour and the distance was 30 miles. So we know that 15 miles per hour is 30 over the time taken. So the time taken is 30 divided by 15 is 2 hours. He took 2 hours to go from A to B. It's also given that he took 3 hours totally. So 3 minus 2 is 1 hour. That must be the time he took to get back from B to A. Now that we have the time it took him to go from B to A and we have the distance, we can easily calculate the speed. So his speed returning is the distance returning, that's 30, over the time returning, that's 1, which is 30 miles per hour. The answer is D. Carly has a dentist's appointment at noon. If she walks at 2 miles per hour, she will be 20 minutes late. And if she walks at 3 miles an hour, she will be 10 minutes early. How far is the dentist in miles? Since I don't know how far the dentist is, let's call the distance to dentist D miles. What do we know? We know if she walks at 2 miles an hour, she will be 20 minutes late. So we know the speed is 2 miles. Let's find out the time she takes. So the time she will take if she walks at 2 miles an hour will be the distance over the speed, which is D by 2 hours. So she will take D by 2 hours to get to the dentist if she walks at 2 miles an hour. What else is given? It also says that if she walks at 3 miles an hour, blah, blah, blah. So let's find out the time it takes her to reach the dentist if she walks at 3 miles an hour. That would be the distance over the speed 3 miles an hour, which is D by 3 hours. Now, how are these two times related? Well, if she walks at 2 miles an hour, that time gets her there 20 minutes late. We don't know the time, but she's 20 minutes late for an appointment. And if she walks at 3 miles an hour, she's 10 minutes early. So what's the difference between these two times? Well, she's 20 minutes late in one case and 10 minutes early in another case. So their difference is 30 minutes. So 30 minutes is the difference in times between time 1 and time 2. Time 1 is greater than time 2 because time 1 is at a slower rate of speed and time 2 is at a faster rate of speed. So I have T1 minus T2 must be 30 minutes, must be 0.5 hours. I have to convert to hours because time 1 and time 2 were in hours. D by 2 and D by 3 are in hours. So let's write the equation. D by 2 minus D by 3 is equal to half. And I take the LCM, I get 6, I get 3D minus 2D is equal to half. So I get D by 6 is equal to half and D works out to be 3 miles. Answer C. Average speed. So let's understand this notion of average speed, which for some bizarre reason a lot of kids find difficult. Let's look at a scenario where average speed would be considered. So say I cycle from A to B at 10 miles per hour and then from B to C at 20 miles per hour and then C to D at say 6 miles per hour. And the distances were different and the times were different. Then what would be the notion of your average speed over the whole journey? Well, obviously the average speed would not be 10 plus 20 plus 6 by 3. That's a very childish understanding of average. That is, oh, you give me 3 numbers, I'll add them and I'll divide by 3 without any understanding of what I mean by average. Here, average speed means were you to cover the whole distance at one constant speed, what would that speed be? So you've got to involve distances and times to calculate this average speed. So the way I would do it is I would calculate the 3 distances from A to B, B to C and C to D, add them up to get the entire distance. Then I'd calculate the times from A to B, B to C and C to D, add them up to get the entire time. And then I know that if I have to cover this distance in this time, my average speed must be the total distance over the total time. So average speed, the common sense meaning of average speed is total distance covered upon the total time taken to cover that distance. And there is no other intelligent meaning of average speed. We'll use this in several problems. Jameel and Afia travel from Arlington to Redmond on 2 separate Sundays. Jameel travels 1/4 of the distance at 15 miles an hour and the rest of the distance at 30 miles an hour. What's he doing? He's traveling 1/4 of the total distance at 15 miles an hour and the rest of the distance at 30 miles an hour. So we can call the distance D and calculate his times for 1/4 of the distance and his time for the rest of the distance. But rather than take D, I'd rather take 4D. Let's see if we can understand why I'm taking 4D miles as the distance. Because I need 1/4 of it and I need 3/4 of it. So 4D will divide nicely into 1/4 and 3/4. So let's just remember that the total distance is 4D miles. Then 1/4 of the distance becomes D miles. And this D miles he travels at 15 miles an hour. So what's the time taken to travel this? The time taken, which I'll call T1, is the distance over the speed. So he takes D over 15 hours to travel 1/4 of the distance. What about the rest of the journey? Well, the rest of the distance at 30 miles an hour. The rest of the distance we know now is 3D miles. So T2 will be 3D miles over 30 miles per hour, which was the speed, and that will give me D by 10 hours. What's his total time taken? T1 plus T2 equal to D by 15 plus d by 10 hours. You can work out this expression, LCM 30, 2d plus 3d, that's 5d over 30, that's 1/6 d. So his total time is 1/6 d hours. Let's see what Afia is doing. Well, Afia is doing something different. Afia is traveling 1/4 of the time at 15 miles an hour. So in Afia's case, the time is given and the rest of the time at 30 miles an hour. So in this case, we need a variable to describe Afia's total time. Let her total time taken be 40 for the same reasons. Then 1/4 of the time is t. T is 1/4 of the time. So what's her first distance? Her first distance is d1 is 1/4 of the time, that's t, at 15 miles an hour. Since distance is speed into time, it's 15 times t. So she travels 15 t miles. What about d2? Well, rest of the time is 3 t hours because t hours is the first 1/4. And the speed is 30 miles an hour. So she covers a distance of 30 into 3t equal to 90 t miles. We have that her total distance, d1 plus d2, is 15t plus 90t is 105t. So total time taken by Jamil was d by 6 hours. And his total distance, if you recall, was 4d miles. The total time taken by Afia was 40 hours and her total distance was 105t. The question is, who was faster? So let's convert one variable to the other. Well, the total distance in both cases is the same. So 4d must equal 105t. They're going on the same journey but on different days. So I get d is equal to 105 over 4t. Now I can compare. So what is Jamil's time? Jamil's time is d by 6, which is 105t over 6 into 4, which is 105 over 24t. And Afia's time we know is 40. Let's work this out. What's 105 over 24? Well, 105 over 24 is surely more than 4 because 24 4s are 96. So this is greater than 4. So Afia is quicker. She took 40 hours while Jamil took more than 40 hours. What is the difference between their average speeds? Recall, average speed is total distance upon total time. And we have all this information for both of them. For Jamil, total distance was 4d and total time was d by 6. So his average speed was 4d divided by d by 6. That's 24 miles per hour. Afia, total distance was 105t, total time was 40. So dividing the two, you get her average speed as 26 1/4 miles per hour. We know it will be more because we already concluded that she takes less time. What's the difference between the average speeds? Well, 26.14 minus 24 is equal to 2 1/4 miles per hour. At 10 a.m., Mr. X started moving from point A to point B at a uniform speed of 2.5 miles per hour. At 11 a.m., Miss Y starts moving from point B to point A at a uniform speed of 1 mile per hour. If the distance between the 2 points is 13 miles, what time do X and Y meet? So here's point A, here's point B. And X starts moving. And after an hour, he's been walking for 1 hour. When he's here, B starts moving. towards him at 1 mile per hour, and he's moving at 2.5 miles per hour. And the question is, at what time do they meet? So there are two parts. One, when X is moving alone, where he's the only one covering the distance between them. And then when they're moving together, when both of them are covering the distance between them. So of course the first part is easy. In 1 hour he moves 2.5 miles, since that's his rate. So what's the distance left to cover? The distance left to cover is 13 miles minus the 2.5 miles he covers, which is 10.5 miles. This is the situation at 11 a.m. when B starts walking. They are 10.5 miles apart and now both are walking. X is walking at 2.5 miles and Y is walking at 1 mile per hour. At what speed are they approaching each other? After 1 hour, how much would A have covered? A would have covered 2.5 miles and B would have covered 1 mile. So they would have together covered 3.5 miles of the distance that separates them. So their speed together is 3.5 miles per hour. They are covering 3.5 miles of the distance between them every hour. And what's the distance that separates them? The distance that separates them is 10.5 miles. So in how much time will they meet? Simple. Distance over speed, which is 10.5 divided by 3.5, which is 3 hours. So they will meet after 3 hours. 3 hours from when? 3 hours from the time they both were walking towards each other. And that was 11 a.m. So 3 hours from 11 a.m. is 2 p.m. Answer C. 2 p.m. Interesting way of solving it. I didn't find out what each covered. I found out what they both covered. Because to meet, that entire distance has to be covered. The distance of 10.5 miles. A will cover some of that distance and B will cover some of that distance. But that entire distance that has been walked is 10.5 miles. And at what rate is this distance being covered? It's being covered at a rate of 3.5 miles an hour. So to get the time, I divide the entire distance that separates them by the speed at which they are approaching each other. Here's another scenario. On a straight road, Mr. X is 450 yards ahead of Miss Y. So Y, X, and this is 450 yards. Both start walking at the same time in the same direction. After 30 minutes, Y catches up and goes past X. So here's where they meet. So obviously Y is walking faster than X to catch up. What will be the distance between the two? 10 minutes after they catch up. 10 minutes later, say Y is here and X is here because Y is walking faster. And we want this gap, the gap that has opened up between them. So X is walking at a certain rate and Y is walking at another rate. And the gap between them is closing because Y is walking faster than X. And what is the speed at which that gap is closing? Well, we can find that out because the gap is 450 yards to start and it becomes 0 yards after 30 minutes. That means Y catches up with X in 30 minutes. That means the difference in speeds between the two, that is the speed at which Y is gaining on X. It's the speed of Y minus the speed of X. That difference in speeds is 450 yards over 30 minutes, which is 15 yards per minute. So Y is gaining on X at 15 yards a minute. We don't know their individual speeds, but we know that Y's speed is greater than X's speed at 15 yards per minute. Now their relative speed stays the same. Y now increases its distance from X at 15 yards a minute. So after 10 minutes, at this relative speed, Y will be 15 into 10. Distance is speed into time. 150 yards ahead. E. Okay. Similar questions, but now they're moving in a circular path, which makes it slightly more interesting. So X and Y start moving along a circular path, 600 meters long, at speeds 25 meters per minute and 35 meters. So fine. So Y is going in opposite direction. They start together and move in opposite directions. So X is going at 25 meters per minute and Y is going at 35 meters per minute. How many times will they meet each other every hour? Interesting. So they are here together. When they meet, wherever they meet, I guess it will be here, where they meet will be beyond halfway because Y is faster. So when they meet the first time, Y would have covered this distance and X would have covered this distance. So they have covered the entire circle between them when they meet. Again, when they meet the next time, Y would have covered a certain amount of the circle and X would have covered the rest of the circle for them to meet wherever they met the second time. Y would have gone like this, X would have gone like this. So again, together they would have covered the entire circumference of the circle to meet again. So every time they meet, together they have to cover 600 meters. At what speed are they covering the distance together? Well, in 1 minute, how many meters are they covering of the circle together? Well, Y is covering 35 meters of the circle and X is covering 25 meters of the circle, and it's different parts of the circle, mind you, because they're moving away. So in 1 minute, they are actually covering 35 plus 25 equal to 60 meters of the circle per minute. So that is their relative speed. Their relative speed is 60 miles per minute. They need to cover the entire circle together. So the time taken would be 600. That is the entire distance they need to cover before they meet, divided by relative speed, which is 10 minutes. So they meet in 10 minutes after they start, and then they again meet in 10 minutes after that, and then again in 10 minutes after that, because in 10 minutes they together cover the entire circle, and they meet whenever they cover the entire circle. First question, how many times will they meet each other every hour? Well, an hour is 60 minutes, and they're meeting every 10 minutes, so I guess it's 6 times. They meet 6 times every hour. They'll meet at different locations on the circle each time, mind you, because the first time they'll meet here, and then they'll meet here, but they meet 6 times in an hour. Second question, when will they first meet at the starting point? So they're meeting at all these different points. When is the first time they will meet at the starting point after they began walking? That's an interesting question. We already know that they meet every 10 minutes. When will they first meet at the starting point? Let's look at X. X walks at 25 meters per minute. And we know that they meet every 10 minutes. So how much does X walk in 10 minutes? He walks 25 into 10 equal to 250 meters in 10 minutes. We know that they meet every time X walks 250 meters because they meet every 10 minutes. So every time X has walked 250 meters, they meet. Now to meet at the starting point, X needs to have walked a certain amount of full rounds to end up at the starting point again. So X needs to have walked 600 meters times number of rounds. X needs to have walked a multiple of 600 meters. So X needs to have walked 2 things. He needs to have walked a multiple of 250 meters to ensure that he meets Y, and he needs to have walked a multiple of 600 meters to ensure that he ends up at the starting point. And we want both these conditions to be satisfied. That means X should have walked a multiple of both 250 and 600 meters. So he needs to have walked a common multiple of 250 and 600. common multiple of 250 and 600. So let's first find the LCM of 250 and 600, because that will give us all the common multiples. Every common multiple of two numbers is a multiple of the LCM. So let's just find the LCM. What's the LCM of 250 and 600? 600, 1200, 1800, 2400, 3000. I think 3000 is the first time both 250 and 600 are divisors. So 3000. Is that true? I can also do it by factoring. Why am I being lazy? This is 5 into 5, 25 into 10. This is 2 into 3 into 10 into 10. So I take a 10 common. I can break up this 10 into 2 into 5, so that I get that 5 from there. So I can take a 10 and a 5 common, and then I take this 2, 2, 3 and 5. So I get 2 into 2 into 3 into 5 into 5 into 10. This 2 into this 2 is 10. This 2 into this 2 is 10. That's 3000. We were right. So the LCM is 3000. So X has to walk 3000 meters in order to meet Y at the starting point. X's speed is 25 meters a minute, and he has to walk 3000 meters. So divide 3000 by 25 and you get 120 minutes. So they meet after 120 minutes or 2 hours for the first time at the starting point. Moving on, similar circular path, but now they'll be moving in the same direction. Mr. X and Miss Y are moving along a circular path 500 yards long at speeds 15 yards per minute and 40 yards per minute respectively. They start together and move in the same direction. So that's the difference from the earlier problem. Here they're moving in the same direction. How much time after the start will they meet for the first time? And how much time after the start will they meet at the starting point for the first time? So similar questions to last time. Only difference is now they're moving in the same direction. So let's understand this scenario better. X and Y are both going together. X and Y. But Y has gone ahead of X. So when will they meet? They will only meet when Y catches up with X. Y goes all the way around and then manages to catch up with X, who's going slower. If they weren't going in a circle, they would never meet because Y is going faster than X and they started together. So Y has to go round the circle fully and then catch up with X wherever X is. So how much distance have they covered? So X covers a certain distance. Y has to do that much distance plus one more circle to come back there. Plus 500 equal to Y distance. And that's the key to all the analysis. Let's see how this happens. What is the relative speed of Y with respect to X? Well, Y is walking at 40 yards per minute and X is walking at 15 yards per minute. So after every minute, Y is 25 yards ahead. So Y's speed with respect to X is 25 yards a minute. How much more distance than X does Y have to walk? Well, he has to walk the 500 yards more. He has to cover an entire circle more than X. How much time will he take to do that? He covers 25 yards a minute more than X. So 500 divided by 25 is 20 minutes. In 20 minutes, Y will have covered 500 yards more than X. And that's the answer. Question 2. How much time after the start will they meet at the starting point? Again, when they meet, they needn't meet at the starting point. So what is the additional condition here? Well, firstly, they have to meet. And they meet every 20 minutes. Now, for them to meet at the start of the circle, Y needs to have walked a multiple of the circumference. So he needs to have walked a multiple of 500 meters. Also, we know that he's meeting every 20 minutes. In 20 minutes, how much does he walk? Y walks 40 into 20, 800 meters in 20 minutes. We know that he meets X every 800 meters and not before. Now, he needs to have covered a multiple of 800 meters just to meet X. And he needs to have covered a multiple of 500 meters just to be at the start of the circle. And since we want both, he needs to have walked a common multiple of 500 and 800, so as to ensure that he is at the beginning of the circle and to ensure that he is actually meeting X. So what's the LCM of 500 and 800? 500, 800. The LCM of 5 and 8 is 40, so this LCM is 4000. So he needs to have walked a multiple of 4000 to ensure that he meets X and is at the beginning of the circle. How much time does he take to do that? Well, he walks at a speed of 40, so the time taken is 4000 divided by 40 equal to 100 minutes. So he'll meet X every 100 minutes at the beginning of the circle. A man rowing upstream travels a distance in 30 minutes. Rowing downstream, he takes 20 minutes to travel the same distance. If the speed of the stream is 2 miles per hour, at what speed does the man row in still water? How does it matter whether you're rowing upstream or downstream? Well, that's the crux of the question. If you are rowing in still water, then only you contribute to your motion. But if you're rowing in a stream that is also moving, if the stream is flowing with you, then the stream is adding to your speed. And if the stream is flowing against you, then the stream is slowing down your speed. So your effective speed changes depending on what direction you are rowing with respect to the stream. So let's see. Let your speed in still water be X miles per hour. Now if you're rowing downstream, that means downstream means the stream is flowing this way and you are rowing this way. Then the stream is adding to your speed and your relative speed will be greater than your speed in still water. So your relative speed will be X plus 2 miles per hour. You add the speed of the stream. This is downstream. Of course, upstream, you are rowing this way, but the stream is pulling you back. So your effective speed is less and your relative speed upstream will be X minus 2 miles per hour. Now we have both the relative speeds and we have both the times. We have the time it takes you to go upstream and the time it takes you to go downstream. Let's calculate the distance. Distance is equal to speed times time. So distance going downstream, distance downstream is speed downstream times time downstream. Time downstream was 20 minutes. And distance going up was speed upstream, which was X minus 2, times the time going upstream, which was 30 minutes. Now, since it's been given that you travel the same distance upstream and downstream, we can equate these two distances to get X plus 2 into 20 is equal to X minus 2 into 30. And solving, I get 20x plus 40 is equal to 30x minus 60, or 10x is equal to 100, and x is 10 miles per hour. So your speed in still water is 10 miles an hour. Rates. Now let's look at rates in general. Of course, we've been discussing rates all along. Speed is a rate. It's the rate of distance moved over time taken. But as we mentioned in the introduction, a rate can be about any work done in a given amount of time. Let's see some more common examples. What is the rate per hour if a tap fills a tank in 6 hours? So the volume of tank we can denote by 1, the entire tank, and time we can denote by 6 hours as given. So the rate of the tank getting filled is 1 over 6 per hour. What does this mean? It means that 1/6 of the tank is filled per hour. It's of course equivalent to saying that the tank takes 6 hours to fill. But here we have it as a rate. How much of the tank is filled per hour is answered by the rate. What are the rates per day when a man working alone paints a house in 3 days and a woman working alone paints it in 2 days? So, man's rate. The entire house can be denoted by 1. That is the amount of work, one house. And he takes 3 days to paint it. So, work is 1, time is 3. 1/3 per day. He paints 1/3 of the house per day. Similarly, the woman's rate. The entire house is 1 and she takes 2 days to finish it, so time is 2. So her rate is half per day. She finishes half the house per day. At what rate is the house being painted if both painted together? So what is the rate of the house being painted now that both are working? So in one day, the man paints 1/3 of the house and the woman paints half the house. So in one day, this is the amount of the house that is being painted. 1/3 plus half. Take the LCM 6, you get 3 plus 2. So 5/6 of the house is painted per day. This is the most important concept in rates. Once you have the rate per person, then you can add the rates if they are working together. And of course, you'll subtract the rates if they are working against each other. If suppose one person was painting the house and the other person was erasing the paint, then obviously the effective amount of paint would be the painter's rate minus the eraser's rate, and so on. We'll see such subtraction when we are filling tanks with taps and the tanks have leaks in them, so the water is leaking out, and so on. So the most important introduction to rates is that it is describing the amount of work done per hour, when we usually take the entire amount of work to be 1. Once we have individual rates per hour, we can add or subtract the rates to get the effective rate per hour at which the work is being done. So let's see the first example. If Sandra can mow the lawn in 30 minutes and with the help of her sister Deepa can mow the lawn in 20 minutes, how long would it take Deepa working alone to mow the lawn? So let's say Deepa takes X minutes to mow the lawn alone. Now, let's find their rates. Rate of work. So what's Sandra's rate of work? Sandra takes 30 minutes to mow the lawn. So there's one lawn and the time taken is 30 minutes. So per minute. She mows 1/30th of the lawn per minute. What about Deepa? Well, again it's one lawn and she takes X minutes to mow it. So she mows 1/X of the lawn per minute. If they work together, what is their combined rate? Well, you just add the rates because 1/30th of the lawn is mowed by Sandra and 1/X of the lawn is mowed by Deepa per minute. So together they will mow 1/30 plus 1/X of the lawn per minute. And what have we been given? We've been given that they can mow the lawn in 20 minutes. So their combined rate we know is 1/20 per minute. Combined rate. It's given that they take 20 minutes to mow the lawn together. Let's equate. So 1/30 plus 1/X equal to 1/20. Please do not take the LCM. Let's just isolate X. So 1/X is equal to 1/20 minus 1/30. That's 10/600, which is 1/60. Therefore, X equal to 60. 1/X was 1/60, so X is 60. Therefore, Deepa working alone will take 60 minutes to mow the lawn. Answer is D. A, B and C have to line a water tank with cement. They can individually complete the tank in 20, 10 and 5 hours respectively. B begins alone and works for 2 hours before A and C join him to complete the task. How long did it take to cement the tank? What's happening is B works alone for a while, completes a part of the task, and then all three work together to complete the entire task. So let's first find out how much B did. As usual, the work is 1. The entire tank has to be cemented. How much of it did B do? B's rate is 1 by 10 per hour, because he can finish the tank in 10 hours working alone. B begins alone and works for 2 hours. So in 2 hours, B completes 2 times 1 by 10 equal to 1/5 of the tank. So out of the entire work that is 1/5 has been done by B in 2 hours. So what's the work left? Work left is 1 minus 1/5, which is 4/5. 4/5 of the tank is left to be done. This 4/5 is going to be completed now by all three. So let's see all three working together, how much they do per hour. That is, what is the rate of all three working together? So to get the combined rate, I add the individual rates. The individual rates are 1 by 20 plus 1 by 10 plus 1 by 5. LCM of 20, that's 1 plus 2 plus 4, that's 7 by 20 per hour. That means working together, A, B and C complete 7/20th of the work in an hour. How much work do they have to do? They have to do 4/5 of the tank. So let's find out the time taken. Rate times time equal to work. Plug in. Rate is 7 by 20. Time is T. I need to find it out. And the work left to be done is 4/5. Therefore, T will work out to be 4 over 5 times 20 over 7. That's 16 over 7 hours. So that's the amount of time they will work together to complete the work. 16 over 7 is 2 and 2/7 hours. Oh, there's no such choice. Thank God. Because if there was, it would be the wrong answer. Why? Because they're asking how long did it take to cement the tank. This 2 and 2/7 hours is just the time they took to work together. But B had worked for 2 hours before that. So the total amount of time that the tank was worked on was 2 plus 2 and 2/7, which is 4 and 2/7. And that's the answer we're looking for. D. Important, always read the question before you pick your answer. Even though you've done all your working right, if you're in a hurry, you will pick the wrong answer. Pipes A and B fill a storage tank in 10 and 20 hours respectively. Pipe C empties it in 8 hours. When the tank is empty, only pipe A is used to fill it to 2/5 of its capacity, after which all the 3 pipes are used. How much time does it take to fill the remaining 3/5 of the tank? It's similar to the previous question, but here A and B are filling the tank and C is emptying the tank. So C is actually slowing down the effect of filling. So C's rate is actually negative. It's not contributing to the filling, it's contributing to the emptying. Let's find the rates quickly. A's rate 1 by 10, B's rate 1 by 20, C's rate 1 by 8, but negative because it's empty. Initial amount of work to be done, 1 tank has to be filled. A pipe A fills it 2/5 of its capacity. So A fills 2/5. Work left 1 minus 2 over 5 equal to 3/5. Now after which all 3 pipes are used. So what's the effective work? effective rate of 3 pipes, 1 by 10 plus 1 by 20 because A and B are both filling it, minus 1 by 8 because C is emptying it. What is this effective rate? The LCM is 40. 4 plus 2 minus 5, which is 1 by 40. So thanks to C emptying it out, the rate has fallen to 1 by 40 per hour. Now let's find out the time. So rate into time equal to work. Plug in. Rate is 1 by 40 times T, and the work we need to do is 3/5 of the tank. That's the amount to be filled. So T turns out to be 3 into 40 divided by 5. That's 24 hours. That's the answer we're looking for. All 3 pipes working together will take 24 hours to fill the remaining 3/5 of the tank.